Hello, for the second problem, I chose question number 13, and it states a 13 ohm coffee maker and a 17 ohm frying pan are connected in a series across 120 voltage source, 120V source of voltage. A 25 ohm bread maker is also connected across the 120 volt source and is in parallel with a series combination. Find the total current supplied by the source of voltage. So I went ahead and drew out my image, and then as you can see here, it's 120 voltage source, and then that's spread out through everything. And then this is in a series, the coffee maker plus the frying pan. And then I went ahead and simplified it over here. So I did the first series is coffee maker and frying pan. It is 13 ohms plus 17 ohms equals 30 ohms. So that's what it is over here. And then we have the 25 ohm bread maker is right here, is connected, and it's in parallel to the source. So this is my completed simplified image. This is just what they described, and this is like easier for me to do all the calculations later. And so I know that since I'm looking for find the total current, that would be I, supplied by the source of voltage. So I know I'm going to be using Ohm's law, which is I equals V over R. And then for this, I had to do RT, which is RT is equivalent resistance of resistors in parallel. So it is basically the sum of the resistance of resistors in parallel. And R, so I said R is sum of resistances of conductors. And then this uses the reciprocal to be able to find this, which I'll get into later. And the SI units are ohm. And then I is our current and is the rate at which charges pass a given cross section. And the SI units is amps, which is A. And then V is our voltage. Well, it is our potential difference. And then this is the voltage between ends of a conductor. So the SI units is volts, which is V. So up here, we basically just have two things in parallel since I simplified it. I just had to add those since they're in a series. And I was able to do the 1 over RT, which is the formula given in class about how to find our total resistance for things that are in parallel. And we know they're in parallel because we have two junctions right here. This separates them, and so that's how we know they're in parallel. Whereas here, they're together and there's no junctions to have to cross. They're going to hit both. So I did 1 over RT, which is basically just taking both of these ohms and then putting them into a fraction. So I did my my bread maker right here, which is 25 ohms. I did 1 over 25, so I just made that under here in the denominator. And then I did my 30, which is the sum of my coffee maker and frying pan. And then, so that's 1 over 30. And then I went ahead and found a common denominator just to make it kind of easier, or just to make it more simple to be able to explain rather than calculator. And I found that it was 150 was your common denominator, so I multiplied 25 times 6 to get 150, so I had to do 1 times 6 is 6, plus 5 over 150 because 30 times 5 is 150, and then we have to also multiply the top, so it's 5. And then it would be 6 plus 5 would be 11 over 150. And then you have to take the reciprocal of that to be able to get your RT, your total resistance. And so it's 150 divided by 11, which is 13.7 ohms. And finally, since I just found that simple step, I'm already given voltage, and it asked me for current. So I'm given voltage right here, 120 voltage source. So I just put 120 over 13.7 ohms, and that gives me 8.8 amps in total.